Okay, so all of this that we're going to be doing today is 4 steps. It's going to take 4 steps to work through this whole problem. So what you're going to have to do is the very first step is you have to balance an equation. I'm going to give the balanced equation for both examples on this page, and I will give the equation on the worksheet, but you'll have to balance it. You're pretty good at balancing them. So our balanced equation, I'm going to go ahead and write it. Oh, I was on the wrong thing anyway. So there's our balanced equation. That is our first step. So step 1 is done. So then we're going to move to step 2. Step 2 is going to be using our formula molarity equals moles over liters. It's very simple. And we're going to go up into our problem and use the numbers that they've given us. So for HF, they gave us 25 milliliters and 0.28 molarity. We cannot use milliliters, so we're going to go ahead and convert this to liters. And to do that, we just move our decimal 3 places to the left. When we don't see a decimal, we know it's at the back. So 1, 2, 3, which makes us at 0.025 liters. And I'm going to write that under HF because it's connected to HF. I'm also going to write 0.28 molarity under HF because it's also with HF. And then if we look over at the rest of our problem, we see that 47 milliliters is connected to MgOH2. Also cannot be in milliliters, so we're going to convert it to liters as well by moving the decimal point 3 places. So that goes with MgOH2. So I'm going to write that under MgOH2, 0.047 liters. And in the problem, they don't give us molarity for MgOH2, so I'm just going to put a question mark for molarity. And when we finish this whole problem, our answer will be this question mark right here. So at this point, I've just filled in what they've given us from the problem. They gave us liters and molarity for HF. They gave us liters for MgOH2, and they did not give us molarity, so that's what we're going to be looking for. So now that everything's balanced, this side of the equation is not going to be useful to us anymore, so we can kind of ignore it. So we're going to go back over to this formula right here. Big M equals moles over liters, and we're just going to fill it in. And we know which one to fill in with by which one has both liters and molarity. So since HF has both liters and molarity, that's the problem we're going to start with. So we're just going to fill these answers, or these units, into this problem. They gave us big M, so we're going to fill that in. 0.28 M is equal to, we don't know moles for this, they didn't give it to us, so we're just going to write mole. And then they gave us liters, so we're going to put 0.025 liters. And from here, we're just going to multiply both sides by 0.025. Since this is being divided and we want to get moles by itself, we do the opposite function, which is multiply. So we'll multiply both sides by 0.025. And when we do that, this lets these cancel out, leaves us with moles. And once we divide or multiply these together, we should get 0.007 moles, because that's what we're left with. And it's going to be HF because those are the numbers that we used. So we're left with 0.007 moles of HF. So that is the answer for step 2. But remember, there's 4 steps, and the 4th step will be our actual answer. So this puts us in moles of HF, but we really need to get into moles of MgOH2. And to do that, we're just going to do a simple mole conversion. And you're pretty good at these. We've done them a lot. So we just put this over 1. We want to get rid of HF, moles of HF. So that's what's going to go on the bottom. And we want to go to moles of MgOH2. So that's what we're going to put on the top. And that 2 goes on the outside of that parentheses I messed up. Okay, Sorry about that. So now that we have MgOH2 on the top and moles of HF on the bottom, we need to know what numbers go in front. So this is why it became important that we balanced this equation. We're going to go back up to what we balanced, and we're going to use the numbers in front. So for moles of HF, we have 2, so we'll put a 2 right here. For moles of MgOH2, we have 1, so we'll put a 1 right here. And then we'll divide, because our number is on top and then our other number is on the bottom. This also allows our HFs to cancel out and leaves us with MgOH2, which is what we want to go to. So when we divide these out, we should get 0.0035 moles of MgOH2. Okay, and that's the answer for step 3. So we started step 3 right here, and we got our answer right here. So at this point, we have our moles for MgOH2. We know liters, and we want to find molarity. So to do that, we're going to use our formula again, which is going to be moles divided by liters, because that's the information that we have. We have our moles, and we're just going to divide by the liters that they gave us, 0.047 liters. And then we will divide that out, and that will be our final answer, which is 0.074 molarity of MgOH2. And I know that's a lot, and I'm going to go through multiple steps with you, but this is just the first one I'm going to send. But it's all stuff you've done, and it's all stuff you are very capable of doing, all stuff you're good at. It's just putting it all together in these 4 steps.